Number 1.7. An electrostatic field is a continuous curve that is a field line cannot have sudden breaks. Why not? That is, see, when we are drawing electric field lines, we draw electric field lines like straight lines, right? Or we draw like curved lines. We are not drawing electric field lines like curved line. We are not drawing like this, right? So this is a wrong representation of electric field lines. Why this is a wrong representation of electric field lines? That it is asked. So see, let us assume I am placing a charge. Let me use a proper pen. Let us assume here I have a charge. This is a field line. Let us assume if I place a charge here at this place, let us assume I am placing a charge here, then what will happen? This charge will experience force. The charge will experience force, and it will be, if it is a positive, it will experience force in the direction of this field, right? And it will move in a continuous manner. Either it will move with a constant velocity or it will be under a uniform acceleration depending upon the field, right? Now suppose if the field has breaks like this, like let us assume this red lines are field which represent field. Let us assume it is wrong, but let us assume it is a field. Then in this case, if I place a charge here, then the charge will experience force. Then in this region what will happen? Nothing, right? Because there is nothing. I have drawn nothing, means there is no field. So either the charge will jump or the charge will stay at this position only. But in real case, the charge will not jump. That is, the charge will move continuously. The charge move continuous only if there is a continuous field, right? So what we can write? A charge placed in electric field experiences a continuous force. The field line cannot have sudden breaks because the charge moves continuously and does not jump from one point to another. The B part, explain why two field lines can never cross each other. We know that electric field line is a vector quantity. So how we add vectors? Let us assume I have one vector here which is pointing in this direction, and I have another vector which is pointing in this direction, and this is the angle between them. So what will happen? We will produce the resultant by considering the angle and the magnitude. This is vector A, this is vector B. So how we will obtain its magnitude? So it is a square plus b square plus 2ab cos theta. That's how we obtain their magnitude. And by using the parallelogram method, we obtain its resultant, right? Means the resultant will have only one direction. Similarly, if I place a charge at this position, let us assume I am placing charge here, then either charge can go in this direction or the charge can go in this direction. That is, a charge can experience force only in one direction. That is, if there are two fields present, then the charge will experience force in the resultant of that field. That is, there will be only one direction is possible, no two direction. That's why two lines are not possible at one point, because if they cross each other, there will be two directions of E, which is not possible. Why it is not possible? E is a vector quantity. So if two lines cross each other, the resultant field will only point in one direction. That's why there is only one direction. See, the field line crosses, but when they cross, they produce a resultant line. So we can see, or we can show only the resultant line, not the two line.